Okay, so let's record it. So, can you hear me, guys? Okay, please chat yes. Hello, hello. Narinig niyo ba, sir? Malinaw ba yung presentation? Okay, sige. So, may mga nag-reply naman. Salamat sa mga nag-reply. Okay, so let's continue the discussion. Situation number 3. So, the figure shows a pre-stressed hollow core slab used for flooring of a library. So, maybe some of you haven't reviewed yet or visited all the sites that I have mentioned in our lecture, first lecture kanina. So, you can look there. Makita nyo doon the actual rebar and concreting of that hollow course. So, given the problem, it has already an area and the section modulus. It has also a slab weight, which is 2.7 kilopascal. We have live load na 2.9 kilopascal. And there's a dimension A tsaka B na 1.2 meters. Wherein ito, A is 1.2, then B is 0.2 meters. Okay? So, superimposed dead load, please take note. When we say superimposed dead load, ibig sabihin, hindi pa kasama yung weight ng slab. Therefore, we're going to consider this 2.7 kilopascal for the slab weight. Okay? Dead load computation. Okay? We have a pre-stressing force, 820 kilonewton. And there's an eccentricity E na 63 millimeter below the neutral axis. Okay? As per problem, it is simply supported on a span of 8 meters. Allowable stresses, may binigay siya na allowable stresses para hindi sumagad yung capacity. So, at service load, 2 megapascal lang daw ang allowed sa tension and 15.5 megapascal sa compression. At pinapakonsider niya yung sama-sama powers ng losses which is 15% at service loads. So, question number 1. Determine the stress in megapascal, the top fiber. Okay, we're going to locate this. So, sa may top fiber daw, stress sa top fiber. Saan? Sa may ends due to initial pre-stressing force. Okay, so solution dyan, that is na problem number 7, that is using mode 3 to. Okay, mode 3 to. Okay, kung kanina may input na kayo, pwede nyo namang i-edit na lang or pwede gawin ninyo is fresh na inputs. Okay, formula, section modulus sa top is moment of the inertia gross over by C top. S bot equals I over C bot. And by formula, stress bottom equals M over S ng bottom. And F ng top is moment all over by section modulus ng top. So what are we going to input now, sir? For this first line, syempre, ganun pa rin. Walang nagbago. Okay, buti pa siya hindi nagbabago, no? Okay, so, PI, initial, minus 1. That is for negative 1. That is for due to axial effect. Then, 1 over by the area. Then, next one is due to bending effect of the pre-stressing force. Since the pre-stressing force is located at, saan siya located, guys? Located daw siya sa ayan. Sabi niya, ayan, eccentricity is below the neutral axis. So therefore, pag tapang ina-analyze natin, it would create a positive. Then pag baba naman, it would be a negative. Okay, so number 7, top fiber. So that is plus. Then sa frequency, our input now will be 1 over by the S bottom. Because here in problem, dito, mahirapan tayong kuhanin yung kanyang moment of the inertia. So, ang given ng problem is the section modulus. So, yun na yung gamitin natin na sagot dyan. Okay, so that's 1 over S bot. For the moment, hindi pa natin isi-solve dito sa number 7 because the problem number 7 is just only asking for stress at a fiber due to initial pre-stressing force. Okay, so input values, yan. So, please match with your input value sa calculator pag nag-solve na kayo ulit. Okay. So, this is the P initial. Wala pang kabawas-bawas due to losses. This is the initial multiplied by 63. 63 is the ito eccentricity natin. Okay, then plus 1. Then ito naman yung 1 over by the section modulus. Dito naman is yung 1 over area. So, CA, shift ups for 5 or shift 135 using 901 is or 570 is, it will create a 1.74 megapascal, which is the stress at the bottom at midspan due to the initial pre-stressing stress. Okay, number 8. Question number 8. The stress in megapascal at the top fiber of the slab at midspan due to low some pre-stressing force. So dito, pina-consider na yung loads, which is yung dead load natin. Okay. And then the pre-stress. Okay, may binigay ba siyang live load? Wala siyang binigay na live load sa problem. So, paano natin yan susolve sir yung number 8? The stress in megapascal at the top fiber of the slab at the midspan. Okay. Ang gagawin natin dyan guys is ganito. Ang gagawin natin dyan guys is ganito. May slab weight tayo na 2.07 kilopascal. Tapos may superimposed dead load na 2 kilopascal. Ayun, may live load pala 2.9 kilopascal. Binigay ba siya dito? Okay. Ayun, may live load pala na 2.9 kilopascal. Okay. Then the value of A or the effective flange weight kumbaga is 1.2 whereby span length 8 meters that is perpendicular sa ating screen. We have a loss na 15%. So if we have initial na 820,000 Newton, therefore only 85% yung magagamit natin sa final pressurizing force. So that would be 697,000 and ito naman is the weight uniformly distributed load. That is yung pinag-add na dead load na dalawa tsaka yung live load at i-multiply sa 1.2. That would generate into 9.12 kN per meter. Okay? Therefore, our moment is WL squared over by 8 as what is indicated on the formula. WL squared divided by 8. Multiply na natin yan ng 1 million. That would generate into 7.3 times 10 raised to 7 Newton millimeter. Okay? So, input lang natin ang values yan, guys. Since gravity load siya, therefore, yung bottom fiber natin, okay, dito sa number 8, siya ay top fiber. Okay, pinapanalyze yung top fiber sa number 8. So, dito, walang labis, walang kulang, negative 1 pa rin yan. Dito naman is final pre-stressing force na yan. Okay? Then, since top fiber at yung pre-stressing force natin is located below the neutral axis, therefore, it would create a bending wherein top fiber is in tension, the bottom fiber is in compression. Okay, so final pre-stressing force yung gagamitin natin yan guys. That is 85% of the initial pre-stressing force. Okay, so that is frequency. Ito, that is 1 over S bottom na because yun yung available na data na meron tayo. Dito naman, M ultimate in newtons millimeter. Then, sa B analysis, yung gravity loads, pag in-analysis natin yung top fiber, okay, that is negative stress yung makuha natin sa top fiber. So that is negative 1. Okay, ito yung magiging inputs natin sa ating calculator. Therefore, ito yung magiging inputs. Okay, dapat mag-match yung inputs natin sa inputs niya dyan. Then, shift ups for 5. This would be the answer. Negative 9.25 megapascal. That is the top fiber stress at the midspan due to the final stress and the service loads. Okay. So, next problem tayo. Yan. So, this is our last problem. Okay. A rectangular concrete cantilever beam, 250 millimeter wide by 300 millimeter deep, okay, is press-stressed by a force of 520 kilonewton at a constant eccentricity of 600 millimeters. The beam supports a two concentrated load of 68 kilonewton at third points of a span of 9 meters. Neglecting the self-weight of the beam, calculate the stress at the top fiber at the midspan. Okay, so dito natin yung ilipat natin. Ayan. Ito yan. Ayan. So, ang hinahanap, number 1, number 10, calculate the stress at the top fiber at the midspan. So, ganito yung analysis yun, guys. First things first, i-secure nyo yung area. Then, moment of the inertia. I-store nyo na yan sa A at sa B. Then, syempre, si pre-stressing force in Newton. At syempre, si eccentricity na millimeter. Dito sa problem na to, cantilever, the problem did not told if where's the location of the eccentricity. But he only said, the problem only said that is at a constant eccentricity of 60 millimeters. So, pag cantilever guys, the eccentricity is always at the top of the neutral axis. Okay, ito yan. Yung red, that red one is located at the top of the neutral axis. Okay, yan yung forces natin located at every third points. 3 meters, 3 meters, 3 meters. And then, of course, if there's a moment, there should be a resistance here, which is 612 kilonewton meter. And there's a vertical reaction there na 136 kilonewton. Okay. Now, for the first one, ito, yung data na yun is maggamit natin mamaya sa number 11. Okay. So, calculate the stress at the top fiber of the midspan. So, isa-isay natin guys. Una, due to pre-stressing force, due to compression effect of the pre-stressing force, all members is subject for compression. Tama? Okay, so that is negative. Mapa-top or bottom stress. Second one, due to pre-stressing force located at the top fiber, that would create into a bending like this one. Okay, so therefore, due to pre-stressing force, itong part na to is negative sa top fiber, then bottom is positive stress. Okay? Bakit nakaganyan, sir? Ganyan yung itsura niya, nakabaluktot ng paganyan. Kasi itong beam natin is magbe-bend pa ganyan. Kukontrahin dapat. Ngayon, kumbaga, nakabaluktot na siya pa ganyan. Para pag nag-bend siya, nag-deflect siya due to gravity loads, is magtutuwid itong linya na to. Okay, from baluktot, itutuwid lang nung force to avoid excessive deflection. So that is the main use of pre-stress materials, concrete materials. Okay? Lalo sa mga SM, ganun sa bridges, highways, skyways. Okay? Yan. So, due to the gravity loads or the applied loads, pag nilagyan mo dyan ng loads, ang magiging effect niya sa bending is pag ganito. So therefore, sa analysis natin, due to moment or due to applied loads, yung top fiber natin, due to the applied loads is yung top fiber is subject for tension, tapos yung bottom is subject for compression. Okay? So, paano natin yan susulbin, sir? Solving mo muna lahat, moment reactions. Dito is number 10 is stress at the top fiber na midspan. Ay, midspan na pala. Ang gawin natin dyan is magpapas ng section sa midspan. Okay? Then magsa-summation of moment tayo mula dito sa, we're going to make summation of moments from the face. Okay, so we will generate a summation of moment which is 102 kilonewton meter. Okay, so if we're going to translate it already in our calculator techniques, shift ups, kung mag-edit, okay, pero mas maganda, input na lang kasi yung problem. Okay, so this will be the input there. Due to pre-stressing force, that is still negative and 1 over A. Due to the pre-stressing force na bending, yung una is compression. Ito is due to effect of the bending. So, due to bending, ito yung itsura niya. Therefore, yung nasa taas is nako-compress, then nasa baba is natitension. So, what we're going to analyze for problem number 10 is the top fiber. Okay, we're just going to analyze the top fiber. So, that is negative. Then, 1 over gross moment of the inertia. Then, next one is the due to moment or the applied loads. So, due to moment or the applied loads, ito yung magiging epekto. Okay? Therefore, top is in tension and bottom is in compression. That's why it is set as positive 1. Okay? Then 1 over Ig. Then, okay, so dapat pares tayo ng inputs. Dapat pares tayo ng inputs, guys, dyan sa calculator nyo. Okay? This is just P. Prestressing force, ito naman is P times the eccentricity na 60. Ito naman is yung moment natin na 102. Galing yan sa dito. Okay? Moment at the midspan. So, solving the equation, then shift ups for 5 or shift 135 sa ating Casio. It would create a 11.947 megapascal, which is the top stress at the midspan. Okay? So, yan, that are the unserviced loads. Okay, number 2 naman tayo. Just go for number 2. Number 2 or number 2 11. Stress at the bottom fiber at the free end. Okay. Bottom fiber at the free end of the beam. Okay. So, free end of the beam. So, save natin. So, bottom fiber, stress at the bottom fiber at the free end of the beam. So, when we say free end of the beam, dito, wala nang moment na kinakarga yan. Ayaw mong maniwala, mag-summation of moments ka dyan, i-moment mo to, ito, tapos ito, i-ano mo na lang, no? By equilibrium, wala nang moment dito. Okay? So, ang mag-act na lang dyan na forces is ito, pre-stressing forces na lang mag-act dyan for number 11. So, gagawin mo na lang dyan, guys, dito sa unang input natin dito, i-edit na lang natin yan. Shift ups 2. Yeah? Yan, input na lang natin yan. Tapos, papalitan lang natin siya. So, since free end siya, tatanggalin lang natin yung moment. Pwedeng, huwag mo na alisin yung data dito. Mag-0 ka na lang dito. Okay? Or kung ayaw mo dyan mag-0, dito ka mag-0. Or dito. Okay? So, yan. Yan lang yung mag-input natin. So, dapat ganito mag-tsura ng inputs natin. Okay? So, that will generate into an answer of 1.387 megapascal, which is the stress at the bottom of the free end. Okay? So, kaya nakalagay na ano, positive 150 dito. Kasi yung due to bending, yung top fiber ng due to pre-stressing ng bending is na compression and the bottom fiber is tension. Okay? And next one is mode 3 to ulit. Edit na lang. Ano yung hinanap sa number 12? Calculate the stress at the top fiber at the face of the support. Okay? So sa face of the support, we have moment there na 612 kilonewton meter. Okay, 612 kilonewton meter. So yan yung gagamitin natin na moment dito sa ating Caltech natin. Okay, input natin. So, parang wala nang ano. Number 12. Ito na pa yung number 12. So, number 12. Kanina is 11. Ito yung input sa 11, guys. Okay. And ito naman sa 12. Okay, edit lang natin. So, pinapa-analyze niya for number 12 is top fiber at the face of the support. So, top fiber yan, guys. The face of the support. Okay. So, top fiber at the face of the support. Okay, so ito, walang labis, walang kulang. Yan pa rin ang input. Tapos, pre-stressing force times the E. So, pag due to bending, okay, due to bending, pag top fiber, that is negative. So, that is why negative 1. Then, M ultimate naman due to the applied loads, pag top fiber i-analyze natin, yung top is in tension. That's why positive 1. Okay, so inputan lang natin itong mga values na yan. That is negative 1, negative 150, positive 150. Okay, so ayun. Huh? Ayan, no? It should be negative C, okay, negative C top. Okay, negative C top. Tapos ito naman is positive C top. Okay, that's why negative 150 tsaka positive 150. So ito P times the eccentricity. Kasi ito lang naman is yung moment natin na 612 kilonewton meter, which is 612 million newton millimeter. And shift ups 45 or shift 135, and it would generate already a 147.947 megapascal. Ano, and also to for our ito yung real application ng pre-stress natin. Okay, so share screen, ay naka-share screen naman. So let me introduce to you the latest design methodology for all structures, ground structures or superstructures, which is the finite element analysis. Okay, ito is galing sa civil FEM. So, makinig ng maig guys, tapos makikita niyo siya. Maganda siya. Okay.
You can pre-stress beams and shells. To do that, you just need a section. Have not defined the section of a tendon, how to define a cable section, casing, how to pre-stress it. There will be an example of a pre-stressing tendon soon as well, and just select which entities to pre-stress. There are no new elements to be defined for the pre-stressing tendon, but the equivalent forces will be applied to the model. For the pre-stressing case, there is an example of pre-stressing as well in the worked examples section. There is a pre-stress load utility where you have to define just the geometry of your tendon, and here when you define a pre-stress load, just select the geometry of the tendon and the elements of the host structural element. In this case it's the full beam where the tendon will be inserted. No finite elements will be created, only the equivalent forces. See here. Here you can see the equivalent forces that will be applied due to the effect of the post-tensioning. You have many options here. In case you are going to study a full pre-stressing, you can calculate losses, long-term and short-term losses, and you can check here both the stress, the forces, and the different.
Ayan, as you can see guys, ito yung mga losses due to friction, slippage, shortening, shrinkage, creep, steel relaxation, heating, thermal stress. Okay? So that's more deeper analysis for the pre-stress for the real job application. Okay?
Losses here for friction, or all of them are displayed here. In case you don't want To include losses, you can set them to 0, so you will have the full force applied.
Okay. That's already the finite element analysis. Okay. Wherein here, the blue ones is not totally stressed, going to green, yellow, and then the red, which is the most stress. So we can find here the stresses. This is there is y component of displacement. So this is in displacement. So 12.11 millimeters yung naging displacement dito nung pinre-stress siya. Okay, yung deflection niya kumbaga. Okay, so you have the option also to change this instead of displacement. You have the option to make it in stress in megapascal or PSI. Yan. So ito yung ano naman pagka patagilid siya, x component of the stress. Yung kanina is the y component stress. Okay? Ayan. Yan naman yung naka-top view siya. So may mga axial forces. So subject for makikita nyo dito, you can see that itong part na to is 3 to 65 kilonewton tong part na to. Which is nandyan yung mga pre-stressing force natin. Okay? So nakakamba siya dito, naka-exage, pero in actual job, nakakamba siya pero hindi gaano kita. Okay?
Thank you again for attending and see you soon.
Okay. So that is the
You can pre-stress beam.
okay. So that is the content of our topic in the pre-stress concrete design. Okay? I-stop ko muna yung i-end ko muna to para ma-record at saka ma-post. Then pasok kayo ulit for some announcements. Okay?